So, good afternoon, all. How many are present? 15, 14. Am I audible? Somebody please reply.
Yes,
Yes,
sir.
sir.
Yes, thank you very much.
Yes, sir, you are.
Yes, thank you. So, we have only 1 hour for revision of entire Tom 2. So, let me present my screen quickly. Let me know the date of exam for Tom 2. Will you please? What's the date for Tom 2 exam?
26. First
Is it
paper
the
is
first?
done.
Oh,
Yes,
it is the first. Okay, no issue. Okay. So let me quickly present the screen so that you have your own time for studying the things. Because this is only a sort of remedial means only we have to go through quickly the syllabus. That's nothing else. You might be referring various books for objective questions. You have got many tools with you on Google. You can search. So you have got the objective questions, MCQs with you online. You can search. No issue with that. Additionally, we have conducted the INSEM, then unit test as well as ENDSEM. So you can refer those also. So let me quickly go through the syllabus. This is unit number 1 on spur gears. So basically, the slide shows you the generation of involute curve. So you can say that I will just highlight the key aspects of each thing, like involute, because we don't have much time for discussion of entire thing. So I will be using minimum words conveying maximum message so that you can appear for MCQs in your exam. So let me change my mode from regular lecture to a remedial lecture. Involute is a curve which starts from the base circle. Involute do not lie inside the base circle. Involute is a curve traced by point on the straight line. Next slide. So this is the way in which I will be engaging today's lecture. I hope you are able to see the next slide. Okay, so this is showing you planes in case of spur and helical. So helix angle is the angle made by tooth with respect to axis. Spur gears, are you able to see the different slides? Please convey to me. I'm changing the slides and you are able to see the different slides.
yes, sir.
Yes. Okay. Yes. So in case of spur gears, teeth are parallel to the axis of the shaft. A spur gear pair gives maximum ratio of 6. Reduction ratio of 6 is obtained using spur gears. As compared to helical gears, lot of noise is there in case of spur gears. Helical gears give smooth operation as compared to spur gears. Two external spur gears rotate in opposite direction, whereas in case of internal external pair, sense of rotation is going to be same. In case of helical gear, LH engages with RH. We can identify end of the helix. This one is RH, this one is LH. In case of helical gears, initially the contact is in a point, finally disengagement also in a point, and gradually there is increase in the contact. The maximum reduction obtained in case of helical is 6. The axes are parallel to each other in case of helical. Herringbone gears are used to avoid axial thrust. In case of rack and pinion, the motion is converted from rotary to linear. In case of bevel gears, shaft angle is 90 degree. Bevel gears are used for connecting two perpendicular intersecting axis shafts. In case of worm gear, the axes are perpendicular and non-intersecting. Dash reduction is possible in case of worm gears, low or high. So high reduction is possible in case of worm gears. The driver is worm, driven is wheel. In case of worm gear pair, the worm is in the form of screw. In case of worm gear pair, axial pitch of worm is equal to transverse pitch of wheel. In case of worm gear, efficiency is low, friction is high, effective cooling is necessary. Reduction ratio of 70 to 80 is possible in case of worm gear pair. In case of involute gears, length of path of contact is a straight line. Angle made by the pressure line in case of spur gears is constant. In case of cyclodal gears, the pressure line changes the inclination. In case of involute gears, pressure angle is constant. Path of contact is the sum of path of approach, path of recess. If two wheels are of the same diameter, path of approach is equal to path of recess. Most commonly used tooth form is 20-degree involute. In case of standard gears, addendum is equal to 1 module. Maximum path of contact is M to N. Actual path of contact is less than maximum possible path of contact. This is very important. This is very, very important. A circle passing through top land is called as, you have got different options, addendum circle. Addendum is height of the tooth outside the pitch circle. Dedendum is height of the tooth inside the pitch circle. Working depth is calculated by deducting clearance from total depth. Face width is axial length of tooth. Top land is the outermost portion of the tooth. Bottom land is the innermost portion of the tooth. Tooth thickness is measured along the pitch circle. Thickness of the tooth varies from base to top. Base is working profile above the pitch circle. Flank is working profile inside the pitch circle. Arc of contact is the ratio of path of contact upon cos of psi. In fact, I'm sorry, cos of phi. Phi is pressure angle. Angle of action is the angle for which the pair remains in contact. The contact ratio should be less than 1, equal to 1, greater than 1. None of the above. Contact ratio should be always greater than 1, so that there is continuous flow of power from driver to driven. The envelope profile will not lie inside the pitch circle. In case of non-conjugate action, velocity ratio does not remain constant. Law of gearing states that common normal to the working profiles at the point of contact must pass through pitch point. The action will be conjugate action if velocity ratio remains constant. The two profiles meeting with each other are called as conjugate if velocity ratio is maintained constant. Pitch point is the intersection of two pitch circles. This we already seen. Suppose if short numerical is asked, then you have to remember this formula: path of approach, path of recess, addition of these two. Once you get Jk, arc of contact will be Jk upon cos of pressure angle. Arc of contact is measured along the pitch circle. So arc of contact is equal to P1, P2, which is Jk upon cos of pressure angle. The size of the gear will be greater if module is greater. Module is the ratio of diameter to number of teeth. Inverse of module is diametral pitch. These are the standard values of module. With increased module, size of the tooth will also increase, size of the gear will also increase. It is written, the size of the gear tooth increases as the module increases. These are the standard proportions of gears. Already we have designed spur helical gears in DME2, so this might have been discussed with you in DME2 also. The driving point should always follow the driven point. This is what the law of gearing says, because this is a case of two rigid bodies. This we have seen. For correct gearing, the normals to the contacting teeth drawn through successive contact points must cut the line through centers of the gears in a fixed point. It does mean that common normal to the two profiles at the point of contact must pass through pitch point all the time. Velocity of sliding. Okay. Interference. Excessive addendum is the basic cause for interference to occur. Minimum number of teeth to avoid interference is given by this formula: twice g upon square root of 1 plus sin square phi into g square plus 2g minus 1. Also, minimum number of teeth when pinion is in mesh with rack is given by 2 upon sin square of pi. Remember that while designing the wheels or the gearbox, the first step is to find out minimum number of teeth. Minimum number of teeth. So, minimum number of teeth calculation is always based on pressure angle. Is always based on pressure angle. So, if pressure angle is 20 degree, what you will do? T minimum will be 2 upon sin square of 20 degree. That comes out to be approximately 18. So, you can form some convention. With increased pressure angle, minimum number of teeth increases. Put phi equal to 20 degree, then 22.5. This will be increased. Okay. These numericals we have already solved. So you may go through the numerical ones. So teeth were given, number of teeth were given, pressure angle was given, modulo was given. So radius is equal to mt by 2. And then using the formula, we found the path of approach, path of contact. Now, maximum path of recess is given by r sine of phi. Maximum path of approach is again r sine of phi. So go through the notes and you can study the numericals. Again, in this numerical, pressure angle is given, velocity ratio is given, module is given, addendum is 1 module, speed of pinion is given as 150, determining number of pairs of teeth, that is contact ratio. What is contact ratio? Arc of contact upon circular pitch, 5 times module. So contact ratio is the ratio of arc of contact upon circular pitch, 5 times module. So arc of contact is path of contact upon cos of phi. Path of contact is jk is jp plus pk. Jp is found, pk is found. In this way, numerical was solved. Now, 220-degree involute spur gears mesh externally and have a module of 10 millimeter. Addendum is equal to 1 module, pinion has 13 teeth, wheel has 50 teeth. Does interference occur? How to check whether interference occurs or not? Basically, remember that the basic methodology to check interference occurring or not depends on if actual addendum is less than max possible addendum, interference will not occur. Or else you have to check minimum number of teeth. If this value exceeds 13, then you can say that interference occurs. To avoid that, you can change phi. The same thing is done. Using this formula, T was calculated, which came out to be 16, and the given teeth were 13, so interference occurred. Phi was changed. Experiment number 1, construction of conjugate profile. Now we shall give attention to the experiments once you finish with your NSEM exam, that is before your schedule is there. We shall discuss all the experiments once again before you appear for your oral practical examination. Just I want to check whether there is something which can be discussed. Now, this is epicyclic gear train. Holding torque is the torque which is needed for fixing the fixed member, that is arm, isn't it? So this we have seen during experimentation, ABCD having different number of teeth, and this was the arm, isn't it? So input torque plus holding torque plus output torque is equal to 0. How to compute input torque? That is torque of the motor, power upon velocity. Holding torque using this load cell, and output torque from the output member was to be calculated. This was the test rig, and different readings were taken. Now, let me close this and let me stop sharing this screen and let me open out the other presentation. Let me present my screen. Just wait. Present now. Window. Yes. Now, in case of helical gears, based on the diagram of that gear, we have to check whether the wheel is left or right. So remember that axis is to be vertical and the line inclination will show the hand of the helix. So for this left one, we can say that the wheel is right hand. Okay. Now, in case of spiral gears, it is going to be a point contact. Spiral gears are used in measuring instruments. They can't withstand higher torque. Okay. Now, this we have seen actually so to say, it is a mesh between the nearer and farther wheel. So nearer will show what it is not, and farther will show what it is. So a right hand nearer wheel will show left, which is false, and the farther, which is say left, will show what it is. This is because for the nearer wheel it is back is in mesh, and for the farther it is front in mesh. So one whose back is in mesh, that will show what it is not, and the one which is on the farther side but whose front is in roll, that will show what it is. That is to be remembered. Helical gears, which are used to connect two skew shafts, are known as spiral gears or crossed helical gears. The helical gears in spiral gearing give a point contact instead of a line contact. Hence, spiral gearing is used for lighter loads. Shaft angle. Now, the center distance between the gears in spiral gearing is the shortest distance between skew shafts. The shortest distance between the skew shafts is the length of common perpendicular to the skew lines. The shaft angle is defined as the angle through which one of the shafts is to be rotated relative to the other shaft about the common perpendicular. Now this we know nearer for farther, isn't it? Now, the shaft angle for two similar helices will be addition of helix angles, and for others it will be difference. Are you getting my point? If the two hands are same RH, it has got 7 plus I2 as shaft angle. Similarly for LH, but if I have got LH combination, shaft angle will be difference of two helix angles. Now this is the formula for center distance between two spiral gears. So Mn T1 by 2 inside this bracket. I think the formula is with you in your notebook. You can refer that. This is also to be remembered. M1 is empty cos of alpha. Many times we have seen this formula. This is actually derivation, which we will skip the derivation. Worm gears, yes, in case of worm gears, the lead angle of the worm is equal to helix angle of the wheel. In design also we have seen that. While discussing worm gears design, we have seen that the shaft angle is 90 degree. That is 7 plus I2 is 90 degree. Additionally, we have 7 plus lambda equal to 90 degree. What is lambda? Lambda is lead angle of the worm. So 7 plus I2 is 90 degree. 7 plus lambda is 90 degree. So lambda is equal to psi 2. Isn't it? Now this we have discussed. Yes. Lead angle is the angle measured from a plane perpendicular to the axis. I repeat, lead angle is the angle made by the helix with reference to the plane perpendicular to axis. Numericals are with you, so I won't spend much time on numericals. You will go through the notes and revise the numericals. Okay. Let me stop the screen and go for the next one. Present, wait, not present. Go to this. Epicyclic gear train. Yes. Let me share my screen. So this is the next unit, epicyclic gear train. Now, epicyclic gear train are actually compact in construction. We have got sun gear, planet gear, ring gear, and the arm. If arm is made free, the ring gear will be fixed. So, an epicyclic gear train is a coaxial speed reducer, or increaser comprised of sun gear, planet gear, ring gear. The gears can be spur, helical, double helical in these gear trains. An epicyclic gear train is an excellent load sharing device. The input torque is split between the planet gears, thus increasing the load carrying capacity of the gear train. Remember that in case of epicyclic gear train, load carrying capacity is high. In an epicyclic gear train, several spur gears distributed evenly around the circumference, and so on. Okay. Now, this we have seen the components of a planetary gear train are divided as housing, internal gear, that is ring gear. Then the driving gear is sun, which is pinion. During operation, the planetary gears which are mounted on a planetary carrier roll between the sun, pinion, and the ring gear. The planetary carrier also represents the output shaft of the gearbox. So what you do, you refer the different arrangements, and probably you have to focus on the sense of rotation. Like I have got driver, idler, and driven. So the driver rotates clockwise. In what way the driven will rotate? It all depends on in between how many idlers are there. If only one idler is there, speed of driven will be same as driver. If there are two or even, then ultimately speed will remain, sense of rotation will change. Likewise, that you have to see. Yes, high ratios can be obtained by connecting several planetary stages in series. The advantage of the planetary gearbox: coaxial arrangement of input and output shaft, load distribution of several planetary gears, high efficiency, unlimited transmission ratio, suitable as planetary switching gear due to fixing. Okay. Lots of theory, we will skip that. We already discussed that. We skip all these arrangements. Now, short numerical may be there that you have to see now, because for NSEM exam, I think such numerical was asked. So you have to remember the procedure. The procedure is to find out the speed. What we do is we go for fixing the arm. When the arm is fixed, the ring gear is made free. Then the table is to be constructed. Number one, arm is fixed and some gear is given X motion. So in this column, you have to write arm first, then 2, 4, 3. Isn't it? What I mean to say is that you have to fix the sequence. Sequence will be arm, then 2, then 3, then 5, and accordingly the table is to be formed. So arm is fixed, so speed is 0. Gear is given, gear 2 is given some motion, so X. Motion of 3 will be ratio of teeth into X. Likewise, add Y to the all elements, and finally add different speeds. Remember that two speeds are always given. First speed is speed of second member. Second speed is ring is fixed, that is speed is 0. Accordingly, you have to find out. So various numericals we have solved. You may refer the notes. So there is no point in discussing the numericals today, isn't it? These numericals are with you. So let me close this and open out the next one. Stop sharing. Close this. Next one is cam and follower. Just a minute. Cam and follower. So present now, window, and cam and follower. Now, similar to gears, the terminology of cam and follower should be studied. In fact, you might have studied the terminology in case of cam and followers. Like trace point is a point lying at the center of the roller or roller follower, isn't it? What is trace point? Trace point is a point at which there is transformation of motion from cam to follower. Cam rotates and follower say reciprocates. So this transformation of motion will take place at a point called as trace point. In case of roller follower, the trace point will be center of the roller. In case of knife edge follower, the trace point is similar to, I mean to say, the trace point itself is contact point, isn't it? So cam is a rotating motion element which gives reciprocating or oscillating motion to follower. So follower has got reciprocating motion, A, B, oscillatory motion, C, both, D, none of the above. So a follower is to have reciprocating or oscillating motion. Now, applications we can revise: IC engines, shoe making machines, punch press, paper cutting machine, fuel pump, diesel engine, blah, blah, blah. Examples for cam: IC engines to operate inlet and exhaust valves. Classification of cam mechanism: rotating cam, translating follower, rotating cam, oscillating follower, translating cam, translating follower. All these animations we have seen, isn't it? So this is a linear cam which moves backwards and forward in a reciprocating motion. This we have seen. Lift is defined as distance traveled by follower from its minimum position. In case of eccentric follower, the axis of the shaft is away from center of cam. Lift is given by y is equal to E into 1 minus cos of theta. Different shapes of the follower are knife edge follower, roller follower, flat faced follower, spherical faced follower. We have discussed this already. According to path of the motion of the follower, I have got radial follower which passes through center, and offset follower which is away from axis. So offset follower has got dash advantage over radial follower, that you have to see. That is discussed already. Classification of cams: radial or disc cam, cylindrical cam, end cam, wedge or flat cam. This is actually end cam, wedge cam. This we have seen. Okay. Oscillatory follower is shown. Examples: control the movement of the engine valves, cam used in a pump. This is very important. Nomenclature is to be studied: cam, follower, base, circle, trace point, and so on. Pressure angle, pitch point, stroke or lift. Motion of the follower, that is known to us. Outstroke is also called as rise. Return stroke is fall. Inner dwell, outer dwell. Types of follower motion: uniform motions, SHM, UAR, cycloidal motion. So we have studied all these motions in detail. And experiment wise, you know how to construct the cam profile, but that may not be your task during MCQs. But still, let me see if anything is missing. Eccentric cam, yes. In case of eccentric cam, the shaft is away from center of cam, and displacement is given by x equal to e into 1 minus cos of theta. This is our setup. Yes, jump speed. What happens at jump speed? At jump speed, there is no contact between cam and follower, and after that event, the follower will re-establish the contact with some thudding noise. So analysis of this. Okay, yes. Let me stop sharing and move to next one. Present now window. Wait. I have to open out that PPT. Gyroscope. So this is actually experimental setup that we have in our laboratory. So gyroscope can be best understood with the help of this setup. So gyroscope is basically a heavy disc having high inertia. And then you're able to see the provision of the weighing panel in which masses can be placed. And then you have got axis of precession as well as plane of precession. The disc itself is plane of precession. Axis of precession, the plane of spinning is plane of the disc. Then axis of spinning you can mark. Precessional plane is bottommost. Axis of precession will be vertical, and the third one will be the plane of the couple, active couple, reactive couple. So with reference to this, you can study that. You have got the videos also. So how to find out the active couple, reactive couple, that is very important, isn't it? Using the thumb rule that we have seen. Accordingly, you may apply this thumb rule to the aeroplane, to the ship, isn't it? So active couple, reactive couple. So the couple which is applied is given by I omega, omega p, where C is the couple applied, I is moment of inertia, omega is angular velocity of spinning, and omega p is angular velocity of precession. Active gyroscopic couple, reactive gyroscopic couple, isn't it? So tendency of couple that is to be discussed, and due to this couple, reactive couple, see what is happening is in case of a plane or a ship, some turn is taken, left or right, isn't it? So because of this turn, the ship or aeroplane has got some effect. So that is to be studied. Using numericals, we have studied that. So gyroscopic effect on aeroplanes. Like in this case, we have got a plane which is taking a turn, either left or right. So what you do, now looking from the front, you have got the spinning taking place in anti-clockwise direction. So you have to adjust your fingers accordingly. Adjust the fingers accordingly. Bend the fingers accordingly. Now focus on the thumb. And what you have to do, you have to rotate this either in clockwise or anti-clockwise. That we have seen. And that will give you the way in which couple is applied. So best way is to solve some numericals, or you have to remember, or you can remember this. Like in this case, the propeller is rotating anti-clockwise direction, and aeroplane takes right turn. So we have indicated that right turn using a red line, red arrow. So what is to be done is, bend the fingers in the direction which is anti-clockwise. Then what you have to do, rotate this. Since it is taking right turn, you have to rotate in that direction. When you do this, what happens is, about this axis, you can say that the active couple is clockwise. So reactive couple will be acting in anti-clockwise direction. So nose down, tail up. So you have to analyze this situation and remember the effect. So when the propeller rotates anti-clockwise, an aeroplane takes right turn, nose will be down and tail will be up. That is the effect. Now, other way. Propeller rotates anti-clockwise and aeroplane takes left turn. What you have to do? Again, arrange the fingers accordingly. Left turn means in this fashion. So what will happen is, the active couple will be in this way. Reactive couple will cause tail down, nose up. Tail down, nose up. Accordingly, various cases can be thought of. Like in place of anti-clockwise, it will be clockwise. Aeroplane taking left and right turn. So two more cases that can be discussed and thought of. So propeller rotates clockwise and aeroplane takes right turn, isn't it? So accordingly, fingers are arranged, isn't it? But slight confusion may be there. Now, right turn in this case will be in this fashion, isn't it? You have to change orientation of the finger and thumb in this way because it is a right turn, isn't it? So you have to be very careful about this. Then few more cases are there. And this was the numerical that is already with you. Some radius was given, radius of turning, and speed was given. The engine and propeller of plane weighs 500 kg and radius of gyration. This was given for calculation of moment of inertia. Then engine was rotating at 3000 rpm anti-clockwise, and then using this formula we found the effect of reactive couple and the amount of couple in this fashion. Okay, so C was I over omega p, omega p I, and these things are known. An effect is to be shown. Okay, so reactive. This numericals are already with you. Then we move to ships. So we have got steering motion, which is shown in top view. So when a ship takes right turn or left turn, that is called a steering. Pitching is up and down motion of bow, isn't it? So different parts of the ship are like this. Referring the top view, this is starboard, right side of the star. This is left side of the star, rear. So this is also called as port. This is stem, rear end is stem. This is front end or bow. Now, the front will focus on this front view. So pitching means up and down motion of bow and stern above transverse axis. And the side view shows you rolling up and down of port and starboard, isn't it? So again, the methodology can be applied. The same thing as in case of aeroplanes. Again, when the rotor rotates in anti-clockwise direction, ship steers to the right. Again, the same method can be used to check the effect of reactive gyroscopic couple. But my dear friends, what you have to do is, there is no limit to what kind of MCQs may be framed, isn't it? So best way is to make your theory sound. Go through the books, make your theory sound. Then you refer different MCQs from our INSEM paper, unit test paper, INSEM paper that we have conducted. Additionally, you may refer the books. At the end of the chapter, different questions are given. Additionally, Sand Foundry or object questions on Tom 2 available on Google that can be thought of. isn't it? Because different MCQs can be framed. There is no limit to that because you have appeared for recently, very recently for in some examinations, and you know experience, you have got experience of different subjects, isn't it? You know different sort of questions, objective questions, and you may expect questions of critical nature also. You might be knowing that sometimes the MCQs are very different from what is available on internet or what you might have seen in the books. I did not explain to you that sometimes MCQs may be from the material that you referred, online or offline or hard books. Sometimes you have experience of MCQs, few MCQs, exactly which are not available anywhere. That's why my methodology, if I suggest, if you ask me, then ultimately go through the books, prepare the theory properly, and then you refer the MCQs. That is the best way to look at these things. Okay. I think this is all about the gyroscope from my end. This was actually the experimentation that we had carried out, and the couple was to be found. But I think experimentation that we have done, I have got the videos for these things. So better, let's finish up the EndSEM exam, and then we will again conduct additional lectures for different experiments so that you can appear for the orals with lot of comfort. Okay. So refer Tom to books, refer the material available with you, refer our notes. I wish you all the very best for your EndSEM exam. Let me download the attendance and then you can leave. Of course, in a short span of time, we can go through the important contents only. So let me scan and just a minute. But for me, since you are in the process of gear design, Term 2 examination should not be difficult for you because you're in touch with gears in DME2. So this will be very simple task for you, provided you study the things in detail. Just a minute. Term 2. This is Excel. Just a minute. In proper folder, I have to save the attendance. Term 2 remedial lecture conducted on March 22 April 2021. And students are 43. My God, only 43 project. Okay. Okay, that's all. That's all for today's lecture. Thank you very much. You may leave the meeting now.